Hello, my name is Danilo Chiarlone and you're watching CanalDFísica. Hello, today's concept is speed, velocity, and acceleration. Well, as I said in my early video, speed, velocity, acceleration, all of these concepts are part of classical mechanics because they explain motion. So does all the other parts of classical mechanics. But first of all, what is the difference between speed and velocity? Many of you may know it as synonyms words, but indeed they are quite different. Do any of you know what is the difference? Well, it's quite simple. Speed is a scalar quantity and velocity is a vector quantity. What does it mean to be a scalar quantity? It means that you have just magnitude, you do not have direction. But velocity does. You can measure velocity as a vector. I mean, you can say, oh, the velocity of that car is 10 meters per second and to the right. As you can see in this train, if I have a train here and this train is going to the right with 30 meters per second and a guy inside the train throws a ball that goes 1 meter per second. A quite fast ball, I can say. Well, what is the speed of the ball? Well, the speed is 31 meters per second. Okay. But the velocity, and I mean velocity in a vector quantity, it is 31 meters per second to the right. Okay. If I take again the train example, but now the guy in the train throws the ball to the left. A guy in the platform will say that the ball, again with 1 meter per second, and the train going the same direction with 30 meters per second, a guy in the platform will say that the ball is going to the right with 29 meters per second. As speed? No, as velocity. Well, so let's now analyze the graphics of velocity. We can see two kinds of graphics. First of all, it's this graphic. As we can see, the value of velocity is a constant value. It does not change when time passes. As the ball had a constant velocity of 1 meter per second. If I throw the ball and there are no other forces that interact with the ball, the velocity will stay constant. Well, but what if it's not constant? What if it describes a parabola? Well, then we are looking at an acceleration in time. So, as you can see, acceleration means that your velocity is increasing over time. your velocity can increase to 1, to 2, to 3, then to 4, uniformly, or your velocity can change like 1, to 3, to then 6, to then 8, to then 9, and there you go. So you have a uniform and a non-uniform kind of acceleration, but basically it means that your velocity is changing over time. This is the concept. Okay, but what's the formula of it? Well, many of you may already know, but as I said, I'll say it either way. Velocity is the change in space over the change in time, or this you can use only in a linear function. But if you want to use a formula that you can use in all the times, you may use the one from calculus, which is dx in respect to time. And acceleration, you can say that it's the variation in velocity over time, or also the derivation of velocity in respect to time, or either you can say that is the change quadratic in space in respect to time squared. And guys, it's important to remember that when the force is equal to 0, I mean there are no forces like this one acting in the body, the velocity will either stay constant or will be equal to 0. Velocity can only change, we can only have acceleration when we have a force, which will be the concept of one of our next videos. I'll be looking forward to seeing you guys. That's it for today.